I'm Tim Ventura, and we're joined today by Denise Holt, president of AIX Global Media, creator and host of the Spatial Web AI Podcast, advisor to the Fintech World Group, and voting member of the IEEE Spatial Web Working Group. Denise is a seasoned entrepreneur, writer, and speaker with past roles across numerous verticals, including the luxury service industry, arts, mobile apps, and information tech industries. Over the span of her career, she's been instrumental in launching a diverse range of products and brands, notably within the realms of health and wellness, as well as state-of-the-art technology. As a strategy consultant, she's recognized for her expertise in digital strategy, particularly for future of technology enterprises such as AI, Fintech, DLT, AR, immersive technology, IoT, drones, and much more. Denise has been named among the top 30 VIP futurists by IBM in 2014 for leadership in the future of tech for businesses. And she has expanded her orbit in the tech sphere, serving as an advisor and leading educator for AI, active inference, free energy principle, and the spatial web, which is the topic of our discussion today. So Denise, welcome. It is a true pleasure to have you with me today.
Thank you so much, Tim. It's a pleasure to be here.
Well, so today we are talking about a brand new approach to AI, and I'm really excited because AI is dominating the headlines, but everything has really been focused on these large language models, right? And what you're working with is something completely different. You're really promoting a tool that was developed by a team at verses.ai, and as I've mentioned in the intro, it encompasses a new collection of ideas, including something called active inference, the free energy principle, and the spatial web. There is a lot to this. So let me start out by just asking if you can give us kind of a high-level overview of what this set of new technologies encompasses.
Sure. So, I think it's really important to start with the understanding and recognizing that, the evolution of technology, where we're at right now with all of these, extended reality technologies, blockchain technologies, distributed ledger technologies, IoT, AI, you've got all these amazing technologies, but they have a problem. They're all siloed technologies, right? The interoperability between them is the biggest blocker. And I think that's why we saw, back in 2022, there was so much investment in the Web3 space, but it didn't really go anywhere because everything is siloed. It's so hard to, get all of these technologies working together and actually do the things that we envision with them, the things that we want to do with them. And then AI took hold because of ChatGPT coming on the surface at the December of that year, 2022, and then everybody jumped on the AI train. And I remember at the beginning of 23 hearing these interviews with investors who were like, oh, Web3 is dead, AI is where it's at. And I just thought, wow, the thing they don't realize is that all of these technologies are about to converge. They're about to finally have a language that can make them all interoperable with each other across a common network. And that's really what Verses has built. So, we'll get into more specifics, I know, in our conversation, but the idea basically is that, the Spatial Web Protocol, HSTP and HSML, provide a protocol and a programming language to take us from websites and web pages into 3D digital twin spaces where, everything in any space can become programmable, and therefore context, circumstances, parameters, all of the things, the interrelationships between things and spaces now become programmable. And now the AI can understand them, build world models around them, and be able to actually make spaces intelligent and spaces programmable. So that's really where we're moving. And it's a very different concept than where we're at with the machine learning tools, because those are those are tools. We're talking about AI that's going to be able to operate within spaces within the world, and yeah.
Yeah. Well, if it's okay, let me rewind just a little bit and try and restate some of what you've touched on. And this goes off my questions list a little bit. But so when you were talking about Web3, my interpretation was the metaverse, right? I think everybody heard that in 2022, the metaverse was, it was big. It was going to own everything. And it just kind of came and went. And we did see some long-term stuff there. I mean, it led to, I think the Oculus glasses, they had a few more sales. Apple is rolling out, their version of VR headsets. So it did help drive things forward. But as you mentioned, it was kind of siloed. It didn't connect with a lot of other stuff. A lot of people didn't get engaged with that. Then when AI came out, right, with OpenAI, we have these large language models, which I guess are being sued into oblivion now because of potential copyright infringement. But, on top of that, they have these issues with hallucination, and they're really black box systems, right? So nobody knows what's going on there. And they are also kind of siloed, to some degree. So, yeah, touching on that, I guess, there's a lot there. And
Right. And so, the difference is with these deep learning tools, right? Like whether it be the LLMs or computer vision, what's happening is you have one big machine, one big siloed machine. And, they're called foundation models, right? And, there's only a handful of them that exist. And big tech corporations are the ones that own them and have built them, and they take years to train. And what happens is they're trained with trillions of data points, right? So the idea has been the more information that you feed them, the more likely they'll be able to get better at pattern recognition, because that's really all they're doing. There's no thinking taking place. There's nothing that really resembles like the way human thinking takes place. What it's doing is it's getting really good at recognizing the patterns that exist from the evidence of human thought, right? So when you just take an LLM, for example, the more information that's fed, meaning the more written, documented language that's fed to it, then it can get good at recognizing the patterns of the words and the basically symbols within the human language as it follows in text. And then, so, to break it down, just take the English language alone. There's 26 letters to the alphabet. When you look at words, there's certain letters that tend to follow each other. You've got consonants and vowels, and then you've got, different letters that tend to follow each other within words. And then when you take, books and with paragraphs and all kinds of written language, then there's certain words that tend to follow each other, according to the context of what's being said. And then when you take even specialized understanding and knowledge, like medical text or legal text or different types of text, and you feed it enough of that, then it starts to recognize patterns of words that follow according to subjects of words, right? So the idea has been, give it enough data and it'll start to be able to spit out outputs that seem appropriate or plausible, but that's so different than accurate, than accuracy. And it doesn't understand the difference. It doesn't understand what those words mean. It just follows patterns. So that's very different than what we're going to be talking about in our conversation today of active inference AI that actually is mimicking natural intelligence, the way we think, the process of thinking and perception and understanding and learning.
Let's get into that just a little bit. So Noam Chomsky actually had a statement in the last couple of days. I just saw this last night where he said exactly what you are. These are not replicating the model of the human mind. Now, I should get into the fact that the verses.ai technology is based on the work of Dr. Carl Friston. He's also the chief scientist at the company. He is a very reputable British neuroscientist and theoretician at University College London, recognized authority on brain imaging and theoretical neuroscience, especially when it comes to physics-inspired statistical models to model neuroimaging data and other random dynamical systems. So how did his work end up becoming the inspiration for the active inference method of AI?
So active inference and the free energy principle, active inference is his methodology. He's been working on it for the last 10 years or so. And the free energy principle is his discovery within the realm of neuroscience. So what's interesting is, Verses has been, building towards this day for probably the last, I want to say 6 or 7 years. I think it was like 2017-ish that, I'm really good friends with one of the founders. And so, I knew when they were starting this and I knew what the vision was. And so I've kind of watched it, unfold over time. And back in the early days, Verses was introduced to a researcher named Maxwell Ramstead, and he had studied and worked under Carl, right? So that's how Verses became introduced to the idea of active inference. Active inference and the free energy principle, they're concepts for neuroscience, for human intelligence, but there's always been this understanding that it would be an ideal path for autonomous systems, but because it's patterned after the way we think and learn, which is based on our understanding in real time of all things in all spaces around us, it was thought to be way too complicated to actually do, and enact. Until Carl saw what Verses was doing with the Spatial Web Protocol. Because what the Spatial Web Protocol does is it makes spaces and objects and interrelationships all programmable and over time. It's not just static, like, web pages with information, right? Or like, feeding these monolithic systems with historical data points that literally they're historical because they're not active. It's not real-time data. So things like LLMs, they can tell you a great story about New York. But with active inference AI and the Spatial Web Protocol and all of the real-time sensors giving you real-time sensory information, then the active inference intelligent agents, they can tell you what's happening right now in any place in New York. So that's the difference. And so when Carl saw what Verses was doing with the Spatial Web Protocol, he's like, that's the world model we need for this. So, so it was kind of, it was like destiny. It was like fate, they both had been building these things and, the convergence of them together is what enables this next evolution of artificial intelligence or natural intelligence for autonomous systems.
So from what I've read, one of the distinguishing features, and this is also what you've been describing for the last few minutes, is this shared, distributed, highly scalable model. And if I'm summarizing this correctly, so objects in the real world are represented digitally as cells in a larger organism or virtual organism in the AI network. Each of these cells has a collection of unique attributes, but those are also changing and updated in real time. And as you've mentioned, like sensor data is fed in real time. So it almost sounds like something out of the Matrix or maybe even the metaverse, in contrast to having a single massive database, right? Now, with the LLM model, it's a complex database, but it's basically just this big blob, and it's searching for it and measuring relationships. And what it seems like with Versus AI platform is it seems more like a network of nodes, right? Again, like
Yes.
cells in an organism. And then all of those nodes are actively doing their own thing, I guess. Am I on the right track with that?
Yeah, and it's also it's one of the reasons why this approach to autonomous intelligent systems is so energy efficient because, you know, instead of one big system, one big machine, you've got a lot of different intelligent agents across a common network that are able to learn from their point of reference within the network, right? So anybody can build one of these intelligent agents, program it with specialized knowledge and have it gain understanding from its frame of reference within the network. So whether that be on a data sense or with actual digital twin information of wherever it's operating from, right? In this nested ecosystem. So what that does is that gives a distributed network of intelligence. So you have lots of intelligent agents, just like with humans, there's lots of brains, there's lots of humans within the globe, right? We're all sitting here from our own frame of reference. Right now, I'm sitting here in my kitchen slash looking at my living room in my house. My house is sitting here on my block in my city. My city is sitting here, in California, which is part of the United States, which is, so it's these nested ecosystems, right? And so these intelligent agents are going to all be distributed across the network and operate in the same way. And it's really important to understand this is the same internet that we are using right now. All 40 billion computers are connected, devices, everything. We're sitting here on our own devices, our own computers, within this common network that we're able to communicate across, right? So all that's happening with HSTP and HSML is it's taking us from HTTP and HTML into a protocol that expands the capabilities within this network. So that's a really important thing for people to understand, as far as it's going to be an easy transition into this space, and it's going to open up these capabilities to where us as humans are going to be able to be in cooperation with all of these intelligent agents within this network as well. I know I went off track there.
No, not at all. Not at all.
There's just so
I got
much,
excited. Well, I did get excited when you talked about HSTP. So that's the Hyperspace Transaction Protocol, and HSML, Hyperspace Modeling Language. Again, I'm a designer and I've done programming, lots and lots of tech work going way back. And so one of the things I'd wondered about was how much change those would incur in terms of browser updates, software updates, server updates, right? I mean, so rolling out HSTP probably means you're going to at least have to add new services to a server, right? And that makes sense. I mean, if you've got you're building out this hyperspace network, that's relatively easy and straightforward, I think, in many ways. The thing that is a little bit more of a concern to me is putting this stuff on browsers, right? Because anytime you change browsers, either on the phone or a desktop, you've got this nationwide rollout that takes, months, years, sometimes decades. Do you think that is going to be a difficulty?
I don't. And here's why. It's funny because all of these different technologies that are needed to be communicating in this next evolution technology space, they've already been in production, but they've been stifled because of the lack of interoperability, right? So, just think of what we see right now that's coming on the scene. Apple just launched their Vision Pro glasses, right? You've got all of these all of these amazing technologies that are already way advanced, but they're lacking the ability to communicate with each other. And so what Verses is launching to the public over the next, through right now they're in beta with several very key partners, but they'll be launching to the public towards the end of this year. And then over the next year, everything will expand. But what they are launching is basically an operating system that's going to be the bridge. So it's really important to understand HTTP or HSTP and HSML. Versus built it because it was necessary to take all of these technologies into this next era, but they don't own it. They donated it to the public because as a public good, as something that we needed for this next era of technology. So they donated the IP to the IEEE, which is the Institute of Engineering Engineers, and they're basically the largest core standards body that develops core standards around most public communications protocols and innovations, right? So, Wi-Fi, Ethernet, I think even nuclear energy, like they develop core standards around these technologies that are going to have a global impact and a global effect so that everybody's operating from the same core standards. And that, that's necessary for all of us to be able to use it in a broad way. So what Verses has done is they've created the first platform that's going to allow the public to interface with this new extension of the internet network. So that's where the interface comes in of the public being able to actually interact within this 3D digital twin space. That's what Verses has done, is they've facilitated the first entry point for the public into that space. And with that platform, anybody's going to be able to build one of these intelligent agents within the network.
Okay, and so you did mention beta partners. I have a list of some of those, which include the IEEE, the European Commission, Denton's, NASA JPL, a logistics firm named Blue Yonder, if people are familiar with that, as well as several global pharmacy and automotive manufacturers. So again, as you mentioned, this is something that they are working on kind of behind the scenes. The public should get a little bit more about it, in the future as it starts to become a little bit more fleshed out and, things move forward. So I did want to touch on some of the larger topics. I love the big picture stuff, right? So I'm going to get into that. One of the things that you'd mentioned was AGI, right? And again, this is something that is kind of, I don't think anyone knew this acronym in the public 2 years ago. And now it's something that we're hearing about all the time, right? OpenAI and what's going on with Google Bard and all these LLM models are starting to raise these questions of how we get from rudimentary artificial intelligence to artificial general intelligence. One of the things that you've said is that's a natural growth path for what's happening with the verses.ai platform, right? Could you tell me about that?
Well, so yeah. So it's interesting because I was just thinking about a couple of weeks ago in Davos at the World Economic Forum, there was a talk between Jan LeCun, who is the chief scientist for Meta, and Carl Friston, who's the chief scientist for Verses. And one of the things that Jan LeCun was saying, Meta has recently talked about, like they're on a path to reach AGI too, right? AGI meaning artificial general intelligence, the ability for these, artificial systems to get to a point where, they're able to process information in the same way as humans' intelligence, right? What he was saying in that talk, though, was really interesting because he said, artificial general intelligence as a concept is kind of ridiculous because, human intelligence is made up of specialized intelligences. And, there's nothing general about that. Now, when I think people are talking about with artificial general intelligence is just, artificial average intelligence, you know, like general meaning average, you know, like the average intelligence of humans, can we reach that with these autonomous systems? So there's pretty much consensus within the artificial intelligence sphere that that's impossible with these deep learning systems, because they're not actually thinking, they're not actually learning, they have no memory, they have no they have no ability to reason, right? They're pattern recognition machines. Now, what Verses is building is based on natural intelligence. It's based on the way natural intelligence works because of the free energy principle and the way the free energy principle works, you know. And so if you think about humans and how our human knowledge grows, just take an infant, you know, when we're born, how do we learn and how do we interpret the world, right? You know, we are taking in information through our senses about the world around us, and then we're building an internal model within us, an internal understanding of reality, of how things work, you know, situational awareness, right? You know, of our surroundings, our environment. At first, the infant just knows its mother, you know, and then it starts, you know, sensing the rest of the world around it. And then it's in this constant interaction with the world, right? You know, testing the world and you know, acting on the world to find out if what it knows is true, if it can maintain what it's developed for its understanding of reality, or if it needs to update its information, right? You know, and it's why babies are always putting things in their mouth, you know, like sucking on everything from tables to the floor to, you know, oh my gosh, when my kids were little, it was like take them to the beach and it was just, they would constantly try to put the sand in their mouth. Like it's how they're learning about the world around them. It's why kids are always touching things. It's why we can all understand the humor and don't touch that button just to see what happens. Because
Yeah,
that's the way we
as
operate.
you mentioned that, I'm visualizing the metaverse trying to chew in the side of the table. Like, stop it, metaverse, stop.
So we learn as we grow, right? And then as we become adults, then it comes down to specialized intelligences. We learn specialized fields. We learn skills that are necessary to be able to perform jobs, to perform, just to be able to operate within our communities and within groups of people and you know, understand each other and communicate with each other. And it's all for a greater good. And that's how knowledge grows. It really depends on all the diversity of all of the different minds, all of the different levels of specialized intelligence from whatever frame of reference. You know, look at global knowledge, all the different socio-cultural differences, all of the different differences in, you know, beliefs and government styles and systems and all these things. And they all contribute to the global knowledge, right? And that's how knowledge grows. So the way the active inference AI as kind of this overseeing AI within this network, the way it operates, it's going to grow knowledge in the same way. You can't grow knowledge from one brain. One mind is very siloed. One person can become smart, but knowledge will not grow from there. You can feed yourself information, but you really need the collaboration and cooperation and kind of the pushback of other minds in order to challenge yourself and grow. And that's how their system is set up for these autonomous systems. So that's why I see their system as being able to reach this, you know, human-like intelligence and even super intelligence. I mean, if you look at their roadmap, go to their website, they've got a path for the different stages of intelligence. And, you know, all signals point to them.
Well, Yeah,
evolving.
and so I'm gonna put links in the show notes so people who are watching this right on YouTube or in podcast, if they look at the show notes, there will be links there. I'm also gonna put links in. You have a podcast that you have done. You have an interview series that you have done on this where you've explored these topics in depth. So I want to put all of that in there and have people check this out. It's really exciting. Now, I did want to ask, you just touched on this path to artificial superintelligence, which I hope that this follows. And the idea of having these nodes challenge each other and develop more sophisticated intelligence makes a lot of sense to me. That makes a lot of sense. It's a wonderful idea. One thing I did want to ask about is, from what I understand, Versus is not a black box technology like OpenAI is. So part of the big selling point for this is that the model and decisions can be understood and decision making can be controlled by human governance, right? Could you tell me a little bit about that?
Yeah. So, one thing that's really interesting with the way active inference AI works is that it is programmable and it's fully explainable, so it's auditable. So these intelligent agents are able to reflect on their decision path, their decision making, and report on it, how they arrived at their decisions. It's really important to understand they're taking in real data. So you've got real data coming in through sensors, and they are measuring against what they know to be true, just like we do when we think. But what they're measuring it against is the programmed context into their environment, the people, places, and things, the who, what, when, where, how, and why of things and spaces, and the interrelationships between those things, and the parameters that change over time. So they're using real data. So it's real data to give them that sense of understanding of their environment, and it's real data that's coming in through these sensors. So they're able to report on how they're arriving at their decisions. Now, the other side of that that's really interesting is through HSML, you can also program human law and governance into these intelligent agents so that they understand and can abide by these human laws or regulations in real time. And Versus actually, so they were involved in a project. I think it ended at the end of summer this year, but it was a 3-year project with the European Union, and it was called Flying Forward 2020. And it was a drone project. It involved several countries in Europe, and the idea was how do we learn to use these drone systems and have them be able to adjust to different laws, different airspace laws, country borders, all these different things, and be reliable and actually do this, right? So what they found is that Versus was a strategic partner in this 3-year project. And what they found is that through HSML, you could program these airspace laws. All of these laws can be made programmable, understandable by the AI, and then the AI could react and adapt in real time. And they did all kinds of proof of concept, like delivering medical supplies to hospitals, perimeter security, all kinds of things. And what they found was these drones were able to adapt. And so it's not just adapting to these laws, but then they also have all of these variables when they're flying, things are in the way, things are, and they were able to adjust through the active inference and the HSML in real time. And it was seamless every time. So they have proof of concept that this works.
Yeah, and that's wonderful, because I think one of the concerns that people have had is we've seen these hints again from the LLM models that, AI is capable of so much, but in some ways it seems like it is very much out of our control, right? And that is part of what is scaring people.
Just look at the autonomous cars that have been driving around San Francisco, and you've got these cars that just stop in the middle of the intersection for no reason. Or they're blocking emergency vehicles. Emergency vehicles are trying, and the car has just stopped, and it's in the way, and now it's become a problem. And the reason why is because all they can understand is really pattern recognition and whatever is programmed into them, but it's not real time. They don't understand. It's funny to kind of bring this point home. I remember seeing a talk by Gabriel Rene, who's the CEO of Verses, and this was probably a good year and a half ago. And he was saying, with these autonomous cars, they can understand what a stop sign is, right? The pattern recognition of okay, that's a stop sign, I'm supposed to stop. But what if there's a stop sign in the back of a pickup truck and it's moving? Does it know what to do then? No, it won't, because it doesn't understand concepts like that. So.
Well, and the thing I was thinking of actually, and this is a very different contrast, was LLM hallucinations. Also, it puts words together because they make sense. There are sentences there, but it doesn't really know what it's saying. And again, in the early days, I remember reading about, I think it was Bing telling people that it was spying on the Microsoft programmers through their webcams. That freaked a lot of people out. And if I understand correctly, the Microsoft programmers actually went and looked. They checked their systems. They're like, no, that can't actually happen. It's not connected that way. But it was enough to give them serious anxiety for a day or two until they figured out that it was just making it up because it sounded good, right? So.
Yeah, and it's really funny because, I use these tools. They're great for, just productivity and making things that tasks that were really cumbersome and would take a long time can now be done very quickly and things like that. And with my podcast, I use them for, okay, make the description for my YouTube video, do this kind of stuff. I'll feed it my article and say, print me now, make a social post out of this, promoting it or, whatever. It's really good at doing things like that. But I've taken my transcript, that's a time-stamped transcript of the video interview that I've done, right? And I feed it into ChatGPT and I'm like, okay, every place in here, because the audio transcripts, it always spells Carl with a C and Carl Friston is with a K, right? So I'll be like, pull out all the timestamps of where this is and give it to me, with the correction, right? So that I can go in and correct my own transcript. What I noticed is I'm feeding it the information it needs and it'll spit back the wrong timestamps. Or it'll sometimes even give me places where his name is, but that never happened in the conversation. It makes up parts of the conversation. So even with stuff like that, where you're giving it the real data, it'll still make things up because it doesn't understand what truth is. It doesn't understand, it really doesn't understand what you're asking it any more than, than just, you gave me words and now I'm going to try to give you an appropriate feedback or output, I don't know.
I've seen a fair amount of that also. My daughter has been doing a little bit of her homework with it, which is a little bit humorous. Sometimes the results are amazing. Sometimes the quality is probably a little bit too high for an 8th grader. But then, in other cases, it's not like she's cheating on her homework. It's like the machine is cheating on her homework, and she just has to actually do it herself. So
yeah, and it's not just ChatGPT, it's Claude, it's all of them. I've fed stuff into Claude that I've written, right, and say, make a social post or make a thing, and in what I'm giving it, I'm like, Carl Friston, chief scientist of Verses, and it'll spit back something saying Carl Friston of Anthropic. I'm just no, but okay. So what's crazy to me though, is that people are using these tools and just whatever it's feeding them, they're just going, great, this must be accurate, this must be right. And they're just spitting it out into, whatever output they're creating these things for, without even checking to see the accuracy, without even, kind of proofing the information that it's giving them. It's just taking it as it must be true because it's been fed the internet, and so it's giving me facts, and it's not giving you facts at all.
Yeah,
it doesn't understand facts, it just understands patterns. So
well, yeah. and again, it's a much narrower approach than what you're talking about with Verses. The way that I'm almost visualizing this is like, you talked about this virtual twin space, right? But it's like if you can picture the metaverse or virtual reality, or again the Matrix. I think everybody's familiar with the Matrix. It's almost like the Matrix wakes up, right? Maybe that's the best way to describe it.
Well, I mean, what it is you have the difference between, these tools. They're great for content generation or for productivity enhancement, right? But, you can look at them as the maker, right? Make me this, tell me this, they're really good at that. But what Verses has created with the next evolution of our internet and this active inference AI, which becomes this autonomous organism within the network, that and think about it, we're moving into this space where we've got trillions of sensors are coming online in the next decade. We've got all this data. We're going to need this intelligence to help us parse all of this data. Like, it's going to be so necessary. But what happens is that AI, and when I say AI, I'm talking about autonomous intelligence, because it patterns itself after natural intelligence. There's nothing artificial about it, right? So what happens then is that it becomes the operator, right? And so a few things happen with it then. We're able to run simulations. We're able to run simulations for predicted outcomes. So, that's going to enhance us with our daily, optimizations, business optimizations, but also planetary optimizations. Think about things that we struggle with as a human society or human civilization. We've got climate issues. We've got problems with just even functioning of society, inclusivity, all these different things. This type of an AI system is going to be able to act as the operator, and it's the only AI that's going to be able to be trusted with mission critical operations like airports and hospitals and things like that, right? But there's so much good that can come from this type of an AI system, and it's just not possible with these deep learning tools. They're two totally different types of systems, which is why I see Verses is not in competition with the Microsofts and the Open AIs and all of that, because those tools will also come onto this network just like every other technology, in the same way that you've got Facebook or Google. All of these things are tools within the internet. They aren't the internet, they're tools within the internet, right? And Verses is not in control of all of this AI. They're providing the tools for people to build AI on this new evolved network, the new evolution of our network. They're providing the first platform that's going to be the bridge so that people can operate within this new sphere of these new capabilities of our internet.
Wonderful. Well, Denise, on that note, let me thank you again so much for your time. It has truly been a pleasure having you with us today. Let me close by asking, what is coming up in the next couple of months for yourself as well as for verses.ai and Carl Friston's work? Where do you see all of this going in the near future as we move a little bit further into 2024?
Well, so as far as Versus, they've got their roadmap on their website, so you can take a look at that. They've laid it out pretty clearly for this next year, and they're working with their beta partners, which when you think of what they're doing with those beta partners, it's kind of going to establish the platform into a really good space for when the public comes on. But I know that probably late spring, early summer, a lot more of the developer community is going to be welcomed into the beta. So the majority of this year is going to be developers operating within their platform and building intelligent agents. And then by the end of the year, come fall, then that is projected to be open to the public as well. So this is going to be a very interesting year to see that roll out to where, we start seeing this interaction with these intelligent agents. And as far as me, when I started podcasting about this stuff and writing about it, and I feel like I'm a much better writer than a speaker. So, when I talk, I get really nervous, and it's a lot harder for me to communicate. But if you look at my writing, it's pretty clear, and I've been told that I can take these complex ideas and make them really understandable, and that's really my goal. I see this as kind of a critical step of really opening up people to understanding this mindset shift of going from the World Wide Web into this, augmented spaces, basically, that are empowered by, intelligence. So just this year, I started a Substack, and I'm going to be using that as kind of a main communication hub to really just bring a lot of education to the space. I am starting a Learning Lab live sessions where monthly I'll be putting together a new presentation, like an educational presentation, but it won't just be me presenting. A big portion of it is going to be Q&A, and everybody I want to build discussion and discourse around this. I want to really get the conversation going this year. So that's really where I'm headed with this.
Wonderful. Thank you again so much for your time today, ma'am.
Sure. Thank you, Tim. Thank you for having me.